In this video, we're going to continue looking at section 2.3 on power, sum, log, and exponential derivatives by looking at problems 6, 7, and 8, and 9. So in number 6, we want to find the derivative with respect to v for y equals d or 5v cubed minus the 4th root of v. Now we can take the derivative of this one directly, but recall we need to convert this first to a fractional exponent. This can be rewritten as v to the 1/4. Now we can use the power rule. So the derivative of y with respect to v would equal 15v squared. And here we're going to get minus 1/4 v because the exponent will be multiplied by the v. And then we have to subtract 1 from the exponent. So if we have 1/4 minus 1, we have to write the 1 as 4 over 4 with a common denominator. That'll give us a negative 3/4. So this is our derivative of y with respect to v. Now we'll do the same thing here. We have to be careful because we have some x's in the denominator for these first two terms. So let's rewrite this expression as a negative 3/4 v to the negative 1. That takes care of the 3/4 and the, not v, that would be an x to the negative 1. That'll take care of that x, turning it to an exponent so we can use the power rule. Here, of course, we write 4x to the negative 3, and here this will stay 1/8 x to the 4th. Taking the derivative of this, then we'll wind up with the negative 1 will be multiplied by the negative 3/4 to give us a positive 3/4. And this will now become x to the negative 2 because we subtract 1. Here we'll wind up with a negative 12x to the negative 4. And here we'll wind up with 4 times 1/8 will give us 4/8, which reduces to 1/2 x cubed. That is our derivative for b. Now, in example 7, it wants us to rewrite this before taking the derivative. We do not have a technique currently for taking the derivative of quotient, which is what we have in 7. So what we have to do is divide these terms. Since we only have a monomial, a one-termed expression in the denominator, we can rewrite this by dividing this out. This will give me f of x is 1 over x to the 4th. Just divide each of those terms by the x to the 4th. Now we're going to clean that up to be f of x. We'll rewrite this as x to the negative 4. And we'll rewrite this. You'll notice that x squared will cancel with x to the 4th and leave me with an x squared in the denominator. So we're going to rewrite that as x to the negative 2. Now taking the derivative is simple. And we'll get a negative 4x to the negative 5 because we subtract 1, and a minus 2x to the negative 3. Much simpler than trying to do fraction. Let's move on to number 9. In number 9, it wants us to find the instantaneous velocity. So it says an object moves along the y-axis, marked in feet, so that its position time x in seconds is given by f of x equals x cubed minus 6x squared plus 9x. Find the instantaneous velocity for the function v. Instantaneous velocity, that is a code word for derivative. So we're going to say f prime of x would simply be 3x squared minus 12x plus 9. Part B asks us to find the velocity at 2 and at 5. So we're merely going to plug 2 and 5 into our velocity function. So f prime of 2 will give us 3 times 2 squared minus 12 times 2 plus 9, which is 12 minus 24 plus 9, or a negative 3. Now this would be feet per second because we want to use units in an application. Then we want to find the instantaneous velocity at 5 seconds. So we'll plug that in here to our derivative function. 3 times 5 squared minus 12 times 5 plus 9. Let's see. That's 75 minus 60 plus 9. 15 plus 9 would be 23, no, 24. Oops, 24 feet per second. Moving on, find the time when the velocity should say is 0. Is 0. So we're going to set our velocity function here equal to 0 and solve for x. So we're going to say 0 equals 3x squared minus 12x plus 9. Now we can find the values for x, which make this function equal 0, either by factoring or by using the quadratic formula. We've seen this before. Let's see if we can factor it, because that is sometimes much quicker. I notice that all three of these terms are divisible by 3. So if we divide out a 3 or factor out a 3, we'll be left with x squared minus 4x plus 3. That does factor. Yee-hoo. That'll factor to x minus 3 times x minus 1. Applying them together, we get 3. Adding them together, we get negative 4. So we know I did it correctly, which means that since we use the zero product rule, either 3, the x minus 3, the x minus 1 must equal 0 if the product is 1. So either x minus 3 equals 0, or x minus 1 equals 0. And that will lead us to an answer. X equals 3 seconds and x equals 1 second. All right, let's move on to our next example. In example 9, we see a classic problem talking about tangents. So it tells us that our function f of x is x to the 4th minus 6x squared plus 10. It wants us first to find the derivative. So let's do that. F prime of x, if we use our power rule, will just give us 4x cubed. And here we'll get minus 12x, and the 10 becomes 0. Then it says to find the tangent line at x equals 1. Well, to find the equation of a line, we need the coordinates of a point. I call that x sub 1 and y sub 1. And we also need a slope. So we can find the slope at 1 simply by plugging 1 into my derivative function. And we can find both coordinates of my point when x is 1 by plugging 1 into the original function. So let's find my point first. We know that x is 1. So if we substitute 1 into my function, we'll get 1 to the 4th minus 6 times 1 squared plus 10. That's 1 minus 6 is a negative 5, plus 10 is 5. So my point is 1, 5. To find my slope, we substitute 1 into the derivative function. So the slope will be f prime of 1, which would be 4 times 1 cubed minus 12 times 1, which is 4 minus 12, or negative 8. So now we can use our point slope form, which says y minus y sub 1 equals m times x minus x sub 1. So my y sub 1 is the 5, and my x sub 1 is the 1, and my slope here is the 8. So we're going to plug those values in, and we get y minus 5 would equal 8 times x minus 1. This cleans up to be y minus 5 equals 8x minus 8. Adding our 5 to both sides, we'll get y equals 8x minus 3. And that would be the tangent line when x equals 1. Finally, we want to find the values where the tangent line is horizontal. Now, horizontal, if the tangent line is horizontal, that means it has a 0 slope. So we set our derivative, which is the slopes of the function, equal to 0. So I'm going to come up here and substitute the 0 in, and then we'll solve it. Once again, factoring is probably the best way to go. If I factor, I can see that I can factor a 4 out of both of these terms and an x. That will give me x squared minus 3. So either, we know the 4 doesn't equal 0. We have 3 things being multiplied here that equal 0. 4 doesn't equal 0, so I can ignore it. Either this x equals 0, making the product 0, or this x squared minus 3 equals 0. Solving this, we could move the 3 over both sides and get x squared equals 3, and take the square root, giving us x is plus or minus the square root of 3. So it appears that my tangent line is going to be horizontal when x equals 0, x equals the square root of 3, or x equals the negative square root of 3. All right. In our next video, we will look at derivatives of exponential and logarithmic functions. Thanks for watching.